formatting my files. I need to figure out what's doing that. Okay, so thank you. Okay, so access, what I'm returning, like not the exact variable name, but the type, what type is coming back. Name of the function. Inside the parentheses are any parameters that this function needs to get in order to do its job. And then all I'm doing is returning make, which is this make right here. Okay?
And that's considered the getter?
That's the getter, because it's literally just getting that value. Remember, nothing outside this class has access to make. So it has to have a method. So, okay, it doesn't have to. It has to have a method to get make if you ever want to return make. There are things you may never want to return, right? A lot of classes have complicated logic structure, like pi, like 3.14. You might not return that. You definitely don't want anybody to set it, right? It messes up all your calculations. Someone decides to change to 6 just for the fun of it. Watch everybody's calculations screw up, right? So if you want to give someone access to that property, you have to do a getter. Okay. All right, so let's quickly, I'm actually going to quickly make more getters. Soon I will show you the shortcuts for all this stuff, but not now. I want you to do it manually. Okay, so let's go ahead and do public string. We're going to do get model. Notice the same pattern here. We're not passing anything because the function itself knows what it needs to do. It just needs to get the model. So we're going to return model. Get your semicolons. Public string color. Return color. Public. Okay, we need to do year. So what do we need to have as our return type? Int. Fantastic. Okay. Return year. Okay, so all of our getters are good. We can now get all 4 of these properties without a problem. Let's go back to our setter. Now, real quick note here. This is a comment. Double forward slashes are comments inside of Java. Okay. This is important largely because the comments don't get processed by the compiler, in case you guys haven't quite. To your file or take out code without deleting it. It basically tells the compiler, hey, don't worry about these lines. I got this. They're just here for the source files. Okay? And that's all I did right here is what I did was I'm like, oh, I need to skip over this. So I just commented all those lines. Now I'm going to uncomment them. In case you're wondering, the command to comment or uncomment, to toggle the line being a comment is actually command and then the forward slash. And it will automatically comment. So if I select everything, like if I select full file and just do command forward slash, it will comment out the entire file. I don't think so, but you can turn them on in preferences. Okay. All right, so let's go back to set make, and I'm going to introduce a concept. It's actually called scoping. Okay, so variables are not available everywhere, right? They're just not. I can't use a variable outside of its scope. Okay, in Java, scope is very strict. In the sense that if you're in a function and you declare a variable, so if we say int hello, and we put 5 in there, it's only available within the confines of this curly braces that it has. Okay? So that's the way you think of it. The scope of any variable is only available within the curly braces that surround it. So in this instance, make, model, color, year, none of these are available outside of this class, specifically the object, right? Because they're defined within car. So nothing outside can just say, oh, I'm going to grab make, because it doesn't work that way. They're confined inside of those curly braces. Okay? And so to that end, inside of a class, the scope for all of those at the top are anywhere inside of that class, right? So if you have an object, it has access to all 4 of those variables anywhere inside. So then the question becomes, that's the same word, isn't it? So string make and string make, there's 2 of those in that class. So which one's it going to make? And this is a guess, I haven't told you, so just go ahead and guess away. Like, don't feel there is a right answer to this question, but it's a right answer I've never told you. So just kind of go with your gut.
I think it's the one that you put in that's asking for an class.
This one or this one?
The bottom.
Okay. Yes. I lost my mouse. This is an argument. Local variables always take precedence over class level variables, also known as class. Okay.
That's right.
Members. So for instance, I can even show you this in action. Okay. So make is Ford. I'm going to come over to car. By that I mean main. Okay. What I'm going to do is I'm going to say car dot, sorry, Mustang, dot set make. Okay. I'm going to pass in just an arbitrary value. Hello. Now, in the event pissing me off, Smalls. All right. It's gotta be. That's all I'm doing this afternoon until I figure out what it is. I'm gonna find this stupid setting that collapses those things. Is that bad? It just annoys me. Like, there's really no reason why you have to not collapse it. I just think it looks nicer if it's full expand. Okay, so this will basically print out whatever the make is. So it's either going to print out Ford or it's going to print out hello. Okay, so let's actually try running it. Hello. Okay, so basically inside of a function, the arguments always take precedence over the main one, or over the class level one, okay? And the whole reason I'm bringing this up is because this is supposed to set the upper one to whatever that is, right? So how do we do that? Let's see, we did the pre-work. Anybody know? Because we have 2 makes. If we call it make, it's always going to pick the one for the function. So there's got to be a way to access the class. Huh?
Say car, not me.
No. We will get to that later today. Although today is slipping away much faster than I anticipated. So we may have to come back this afternoon. Okay. This, okay? So this is a special keyword that basically says this object, the object I'm currently inside, that's what this means. So if we do this dot make, this right here is saying this, which is car, make, which is this variable. This is how you access things outside if you need to be explicit about things outside, inside your class, but outside of the given method. So now this works fine. Okay? So to that end, if you really want to be explicit, all of these down here should technically be this.make, this.model, this.color, this.year. Okay? this is explicit. Now, the way Java kind of helps you out is in the event that there's only one of those variables, like you don't have that variable in your function, it just automatically looks for the class. I think it's a weird thing. I actually find that very bizarre because Java is so verbose about everything. You would imagine you would always have to do this dot, but you don't. Okay. The big times you use this dot for variables usually happen in setters or in a constructor. The constructor is what we're going to go over next. Okay. So basically, that's all that is, right? Is that this accesses the class itself. Does that make sense? I know that it's kind of a weird concept. But the other thing is that say like in this one right here, I need to call getMake. So like we need to do a getMake. You can technically call getMake, or you can do this dot getMake, right? So this is mostly just used, the keyword this is mostly used in setters and constructors, and that's it. But it is very important that you understand this concept. Okay? So I'm going to go ahead and I'm going to repeat myself, and I'm going to do public void set model, string model. We're going to go ahead and pump out a couple more of these. Okay. Any questions thus far?
Do you have to do one of those for each of the get things?
You don't have to. Remember, setters and getters are only needed if you need to set and get properties inside of the actual class, right? You don't need them. You don't put them. In fact, I'm going to do an example here in a minute of when you would not have setters at all for a lot of these things. Okay? And we'll talk about this where constructors come in and methods come in. Okay? So is everybody comfortable with this? And by comfortable, I mean, does everybody think that they could possibly redo this if they needed to? You seem very unsure.
I'm not quite sure.
Okay, is there something specific you're not sure about?
You know, it's probably just a whole bunch of stuff all together at this point.
And that very well could be. You guys have had a lot for into already, and we have a lot more to go. Okay. But unfortunately, like I've said, there's really no alternative. One of these days had to be that, because I have to give you enough information for you to do like a weekend project, which means you have to have the basics of Java.
Yeah, I'm sure if as we go through more things.
Okay.
I totally, you are recording this, right?
Oh yeah, I think we're recording. In fact, there's going to be this really nice 10-minute gap in the recording where I totally forgot to turn it off. Yeah, so there's going to be the engineer joke, which we're not going to go in there and actually rip it out.
I was too busy trying to keep up with you until like the last 2 minutes, where I felt like I was constantly one step behind. I was trying to follow the code instead. I should have just kind of paid attention to you.
It's a tough call.
It was, yeah.
So, all right. So now what we're going to do, tell me something. How often does a car change its make, model, and year? Never. Right? So going back to this concept, should we really have setters? Well, we need to set it once, right? But we never really set it again after that. Why would you? Make, model, year. Like it's just, you wouldn't set it again. So let's talk about constructors, okay? What a constructor is it's a special function that runs when the object is created. And what the constructor does is it allows you to pass in, say, initial values for the object so that when the object is new, you remember how like we had to do make equals this, model equals this. In this new way, we would still have to do set make equals this, or set make this. set model this. That's not super helpful, because what it means is that we can create a car that is not in a state that is ready to go. You cannot use it when you do new car, right? You have to set all this stuff up first. That's not really helpful. Here's where constructors come in. They make sure that you can give it enough information, you're like, bam, here you go. Okay? Now you don't always use constructors, but for the most part for you guys, you're going to use constructors a lot. Okay? And the way we do a constructor is, we're going to do public. There is no return type for a constructor. It's the only method that does not have a return type, including void. And what the constructor is the constructor must be named the same thing as the class. The public, and I'm just going to call it car, okay? It is a special way of doing things called a constructor. Now, what things are never going to change? Out of these four, what are the three things that are not going to change?
Make, the model, and the year.
Make, model, and year, right? And this isn't a programming thing, it's a conceptual thing. Like, once the car is made, these things never change. So once the car is instantiated, those things never change, right? And this is why constructors are fantastic. So what we're actually going to do is we're going to go ahead and we're going to accept all four of these as attributes coming in. So we're going to do string make, string model, string color, int year. Okay? This is the first time you've seen this. This is a method that accepts 4 different parameters or 4 different arguments for it. Okay? There's no reason you can't do that. You have 1, you have many. If you're going to do multiple, make sure you separate them with a comma, otherwise bad things happen. Okay? So then we're going to do the same thing we did with the setters, except we're going to do them all at the same time. So I'm going to do this dot make equals make. Going back to we have 2 makes. We do this dot model equals model. This dot color equals color. And this dot year equals year. Okay, so since make, model, and year never change, we probably don't need setters for them, right? We don't want people to arbitrarily be able to come in, take an object, and change the car, right? That's kind of shady. It's like used car salesman shady. It's like, oh no, this isn't a 2007. This is a 2015. Yeah, totally. Okay, so what we're going to do is we are going to come down here and we're going to say, you know what? You are not allowed to set make, model, or year. So when the constructor happens, the object is created, all of these things are set, and you can never set them again. The only thing you're allowed to reset is a color, which I have seen people do. My favorite color currently is that not glossy, kind of like gunmetal black. That is a cool color. You didn't ask, but I'm telling you. In case any of you like leave here and immediately become super rich with an idea and want to give me a gift, a car with that color all the way. Okay? All right, so now if you'll notice, it's interesting that I'm doing this. I'm actually trying to make the class increasingly more difficult to do anything, right? It's kind of weird, but you really want to do this because the less the user can do, remember, you're trying to encapsulate this class. The class should have control over what it's doing. So this class allows you to set it once and then no more, which is totally fine. But those type of controls are how you can make your classes much more robust. Because if you create this car class and I import the car class, I take your code and I put it in, I want to use this car class to make an object. It needs to be as clear as possible what it does. If you have no ability to set the objects make and model after the constructor runs, I know that that's it. I need to be careful with that, right? It's what we call self-documenting code. Okay? So there's no documentation in this code. There's no comments, which we'll eventually get to. There's none of that. But it's okay because it kind of tells me what's happening. All right, so we only have one setter now. And since we're doing this, we can actually go up here and we can wipe all these out. Now, in general, if you were going to have nothing declared at the top of your class, you know, that whole if make is nothing, then you need to make sure it's specified in the initializer or in the constructor. Make sure it's specified in the constructor. Otherwise, you have a chance that it's never initialized, which means that that variable is kind of just sucking from the ether. It doesn't actually mean anything, okay? So now that we have this, we've got actually a really, really nice, kind of concise way of doing things. So now if we want to make car, if we go back to main will actually have an error, right? See the error line? Because it's expecting all these things that we never gave it. So what we're going to do is we're going to do, so if you hold command and hover over a function, it will tell you what it's expecting. Super duper useful. Okay, so what we're expecting is make, model, color, and year. So I'm going to do Ford, Mustang, black, 2007. Okay. We also have a red here because I was setting the make, and we no longer allow you to set the make. Okay. Everybody with me on the constructors? Okay. Constructors are really, 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 really useful. Sweet, 1057, perfect. Okay, so let's actually do something a little bit more frivolous in the car. So thus far, all of our methods have either been a constructor or getters and setters, right? The only example we have that is not tied to the actual getting and setting of the object itself is square, right? But square is not super useful in car, so I'm going to delete it real quick. And we're going to do something a little bit more useful. Public. Not going to pass anything back. I want a honk, or honk horn. Honk horn. Not going to pass it anything either. I'm just going to say system dot out dot print line. Beep. Now, if we go back to main, we do Mustang honk horn. Go ahead and run it. Now it beeps, right? So the key to showing you that is I want to make sure you guys understand that sometimes classes just need to contain logic. They don't necessarily have to accept arguments or send back arguments. They just do one thing and they're done, right? This isn't setting or getting, it's just basically printing out leave. Okay? And that's kind of the method. All right, questions at this point? It's a good time for it. What is that?
I was just one step behind you this entire lecture.
It's okay. You don't have to necessarily keep up. Okay. So this is what your class actually looks like. You'll notice that we've actually removed a lot of code. Now, an interesting part of the real world of software engineering is some of the most beautiful code is code that you've stripped down. Do you ever hear that quote that basically says, "If I had more time, I would have written a shorter letter," right? Like, not having code, making your code very concise, is way, way better than having lots and lots of code. In the early days, they used to basically judge programmers based on how many lines of code they wrote per day, which basically meant that you had really, really ugly code immediately because you're encouraging people to write a bunch of extra lines that you don't need. Okay. Alternatively on this, what I'm going to do on this one is I'm actually going to be committing and pushing it up into a class notes repo inside of the GitHub organization. So you will have the end results of this sitting waiting for you.
Awesome.
Okay. Yeah.
Is there a way to measure your program's efficiency?
There are ways. It is way outside of the scope of what we're doing right now. But there are actual programs that will show you how efficient your code is. A lot of the is it truly beautiful code is going to come from your coworkers, right? If you can go in and read it and immediately understand what it is and you didn't write it, that's good code. So
What do they base those off of? Is it just like cycles?
all of the performance ones are based on like how many iterations and how long each of the instructions are taking. When you're talking about extremely fast processing, any type of mistakes can be a big problem. So we got fast enough that there were actual like loops that we ended up caching because they were taking up significant amount of time at Zappos. So, all right, so this is our basic class, okay? Nothing too complicated. It's really close to what we call a model. In the sense that, and you'll learn about models in a few weeks. Really easy, very simple to use. Let's take another example. What about mileage? So, private miles, private int miles. I want you to go through this logically. Should we have a setter? Should you be able to change the miles?
Yeah.
Mm-hmm. But here's a question. Should you be able to arbitrarily set miles to whatever number you want? Why is that?
It's going to be changing. It's not set. It's not defined.
Yeah, right? You're going to start at 0. You're going to go up from 0, right? You never want someone to set it to 2, right? Oh, I have 10,000 miles. Oh, you have 200, right? Kind of shady. You don't want to do that. All right? So for mileage, now, here's the reason why. Like I told you thus far in this lesson, I told you that you use getters and setters because you never want to directly access those members, like the actual variables, right? The reason you want to do that is you want to be able to institute logic for those, right? So you may have a setter, but maybe you don't want that setter to ever let you go below -1 or go below 0, okay? Maybe you want the setter to do other logic. Now, another fine example of this is say like you write a program and you accept a user's name. So we create a person object and you accept their name. You know, what's your full name? My friend goes across. What's your full name? Huh?
The board over minutes.
I feel like Nigel had this right. Well, what's your full name? Valerie what?
Joyce, yeah.
Perfect. We're using hers. All right. So, you know, Valerie Joyce, right?
Okay.
And so, huh?
Joy, just do it.
Joy.
Yeah.
Yeah.
So if you go to a startup company after this, can you please promise me you will request your name, your email address to be joy@whatever? Because that's amazing. Okay. So when you first start this program, everybody's just passing you their name, right? First name, last name. That's all they're doing. So you store, in the person class, you store Valerie, Joy. The whole string. As you become more sophisticated, you're like, oh crap. We really need first name and last name. Okay? There's a lot of programs. There's a lot of, like, you've created this class. Every bit of code in the entire company relies on get name. But you don't want get name do. You don't want name, you want first name and last name. What do you do? This is a big problem. Because if you change it, you immediately break every bit of code talking to it, right? So in the event that everybody, you've done all your variables as public, everybody's just going person.name. Well, there's nothing you can do about that now. You're screwed. You have to have them change their code. But if you do it this way, what happens? People aren't accessing name directly. They're using getName. So now what you can do is you can change your code, and you can say, when you do setName, it automatically splits the string and puts it in first name and last name. Has anybody changed anything? Nope. You've changed the underlying code. Then when they get name, right? Well, you don't have a name anymore, but it doesn't matter. What you do is you say, here's the name. First name plus space plus last name. And you're passing back exactly what every bit of code has always wanted you to pass back. But now you are serving back two variables as one. So your code, the code that you need to change, has changed. The code that everybody else is using has not changed. Okay? So this is amazing for scalability. In a lot of senses, this is part of the reason. So Java is used in enterprises. Why? Because Java has a tendency to be more verbose in small projects, but is more resilient and resistant to creating what we call spaghetti code with lots and lots of people. Because if you have some company that has a 5-year-old Java program, and there's millions of lines of code tied to this one system, this one library, you can't just go changing that library. Java forces you to be more verbose, which means in the event that something happens, you can change the underlying code. No one has to know. What we call the API doesn't change. Their ability to connect into you or how they connect into you doesn't change. Okay? Big boon in large companies, because unfortunately in large companies, you don't know what's going to change. And you get to a certain point, it's just so huge, you can't change it anymore. Unless, of course, you're following these type of guidelines, at which point it's like, oh, well, we might be able to change the underlying code. We won't break you. And then what you can do is you can say, eventually we're going to deprecate getName. We're going to deprecate setName. When I say deprecate, we're basically saying, we are making this so that you know I'm not updating this anymore. And in a few versions, this is coming out. So it gives you plenty of time to change your code, plenty of time to pull out stuff, and move to the new system. Okay? That's why we do this type of stuff with classes. It's specifically so we have the option of doing something crazy if we need to do something crazy. Okay? So let's look at miles. Miles should only ever go which direction? Up, right? So if we do a set, kind of messy because anybody can set it to anything they want. We can't really, we could theoretically compare it and make sure. But a lot of times what you end up doing is you end up setting variables to something the user can't change, and then you create a method. So instead of doing a setter, you just create a method. Okay, a normal, actually, setters are just methods, but I'll show you kind of what I mean. Okay, so instead of doing, if we were to do public void set miles, and then we take an int miles. Okay, you all brought up the problem that now I can basically set miles to anything I want. That's not good. So let's not do that. Let's take that option away because this is our class. This class is responsible for making sure that you can't do something stupid from the outside. So we're going to actually pull out set miles, and what we're going to do is we're going to change this so subtly. Add miles. Okay? When you name your functions, the function should be descriptive of what you were about to do. Add miles. So now, instead of setting the miles to this, we're going to add this miles to the top miles. Okay? Because that's what we're saying we're going to do. You pass me miles, I'm going to add miles. So now what we're going to do is inside of here, really simply, nothing super complicated here, this dot miles. Now, here's where your shortcut comes in. If we were to do this the normal way, equals miles, or sorry, this dot miles plus miles. Okay? So this is the way we would normally do it, right? I'm basically saying take the result of this miles plus the miles that have been passed in, right? And putting it into this miles. So if this is already 10, this is 10, it adds them together 20, and 20 split back into miles. There's a shortcut way to do this. It's a fantastic shortcut way. Everybody uses it. All the cool kids are doing it. Plus equals. This exists for every major one. You can do divide equals, multiply equals, minus equals. It basically just says plus equals is a shortcut of saying whatever's on the left, take whatever's on the left, do it on the right, and then put it back into the exact same variable. This happens a lot. Questions on this? Okay.
Shouldn't miles be double? Because you have to
Yeah, it totally can be double. At this point, I wasn't worried about it too much. Okay. Now, interestingly enough, let's actually look at this again. It returns what? What is the method return? Oh, it returns nothing. Okay. Let's think about it. What should it return? Or should it return anything? There you go. And this is all, we're like, I'm tiptoeing into design a little bit here, but I want you to think about what's useful, right? If I add miles to a car, if you don't give that back to me, what do I have to do? I have to basically go add miles, get miles, right? I have to get the miles out of the system again after I've added it to make sure that my math is the same as their math. Or, as a nice convenience function, we just simply change this to int and return this dot miles.
to return this miles plus equals
No,
miles.
you actually have to do both of these. You can try it. This point in time is not worth the code saving, which is something I'm going to drill into you over the course of the semester. There are times when you can write something all in one line or very concisely that I will probably say this works fine, now change it. Part of your responsibility as software engineers, please make it so that someone else can read your code. Like, I know people who, there's ways to do what we call ternary operators.
But yeah,
So instead of doing if, else, if, that type of stuff, you put them all in one line, and then they'll nest them. So you have basically, it's like an if statement and another if statement embedded in it, but they put it all in one line. It's impossible to follow. At that point, they basically saved 8 bytes of code to ensure that absolutely no one can read your code, right? Don't do that. There are ways you can make shortcuts, but the shortcuts are usually useful. If you go overboard, which is totally possible, you will make your code completely unreadable, and it's just not worth it. It's not going to help you. It's not going to. Another key concept is any code written by you 6 months ago might as well have been written by another person. You just don't remember, right? You code all the time. You're not going to remember what you did 6 months ago. I actually use a process called recursion, where a function method calls itself over and over and over and over again. That's Avros. And it was useful. It is an actual, like, it should have been done that way. The code is much more concise than the original code. The problem is it's also much more complicated, which means when I went back 6 months later, I'm like, I don't remember how this works. I had to, like, deconstruct it again because your brain doesn't hold on to that crap. If you have a photographic memory, kudos to you. I wish I did, I don't. So most people don't. 6 months, you're gonna have to go back. If you write really clean code, you can go back and understand your own code. Because there's nothing that will inspire self-loathing as much as going into your code and hating it, okay? Because you didn't write it. I still do it. So I have a side project I work on, this crowdfunding site. It was written in Django and Python. Guess what I didn't know how to do when I wrote it? Django or Python. It was the first project I ever wrote in that language and in that framework. A year now, I've been teaching Django and Python. I know these systems very well now, which means I go back and look at the code and it upsets me. I want to go back and punch myself in the face because it's terrible. There's so many things that need to be changed. Okay, so write clean code if you can. Okay. All right. So now that we have this, add miles means we can consistently add miles to this object, so specifically the car, and it will always go up. We don't have to worry about it going back down. We don't have to worry about someone monkeying with the system, or do we? How do you cheat our system? How do you cheat the system? We've made it so you can't arbitrarily set the miles. But what is an integer?
But it can also be a negative.
There you go. Be a negative number. So if I add miles, if I add 10,000 negative miles, right back down. Okay? So this is going to bring us to our next major concept that I kind of need you to understand. Now, it's going to take a little while for you to really get into this specific idea of exceptions. So I'm going to take it a little bit slow. It's like 11:17, right? We're going to take it a little bit slow. I want you to ask lots of questions, okay? Now, everything is an object. And when you look at how a program functions, right? If I come here, in fact, what I'll do is I'm actually about to run the debugger. I'm not going to show you the debugger quite yet. I'll probably save it for tomorrow when we get into conditional statements. The debugger is invaluable, okay? So what we're going to do is I'm actually going to honk the horn, and then I'm going to go ahead and I'm going to add miles. I'm going to add 1,000 miles, okay? The other thing I have to do right here is miles is never set, right? So taking a step back, miles is never set. What do you think is going to happen when someone tries to add miles to this car? It's actually going to blow up because the code's wrong. You have to set miles somewhere. You cannot add to something that's not a number yet. Okay? Because if I say add 1,000 miles, what is it adding to? Yeah, it's literally nothing. The variable does not have a value. It will eventually be an integer, but there's nothing in it right now, so you can't add 1 to nothing. It doesn't work. So what you actually have to do, in fact, it'll probably warn us if we don't do this. You either have to say miles equals 0. More likely what I would do is I would do this right here, which is just basically this miles equals 0. I like keeping that type of stuff in the constructor because that's kind of where it belongs. People would be looking for it. Additionally, hopefully to help anybody who's still struggling with this, this and what's class and what's not, I don't have to put this. The reason being, there's no other miles in the local scope for the variable, which means it just says, well, I have no miles, so I'm going to assume you mean the class level miles. Make sense? And I'm only doing that just because I know some of you had that look of horror and confusion on your face. And after a year of teaching, I've learned to identify the look of panic and terror. Okay? All right, so we've now initialized it. So let's come over here. Now I'm going to do something that's going to show you an exception. Actually, I'm going to go ahead and do debugging first, and then I will show you an exception. Now, debugging, I will do a more in-depth lesson about this, like I said, probably tomorrow. But we need to kind of see it to begin with, okay? This is called a breakpoint. I just clicked over here, and it puts a little dot. What a breakpoint does is it tells the program, if you're debugging, stop here. Hold up, pause the program. And the nice part of debugging is you can walk through your program while it's running, right? Otherwise, what you do is you put about 900 system.out with print lines in there and just print out what it is. This way you can just walk through, okay? And we're about to walk through. Just click over here on a line. Okay, like I said, I'm not going to dive into this. I'm going to let you guys have one more night of kind of playing. And then tomorrow, I'll try to tack on a lesson about debugging, because I think debugging is one of the most valuable things. I used to do PHP before there was really good PHP debuggers, and it was terrible. Because if something went wrong in your program, you literally just printed out variable values throughout your whole program until you found out what happened. Very, very inefficient. Lots of running the program. Okay. All right. So I'm going to go ahead. I'm going to run it in debug mode. Okay. You don't really have to follow along with this yet. Okay. So now what happens is we run it. Now this is just like running it normally, except now it's in debug mode. You notice how it highlighted the line? My program is still running right now. But it's running and it's waiting. Because I asked it at a breakpoint, hey, hold on 1 second. Okay, so it does that. And so we come in here and we're like, all right, fine. And what I'm going to do is I want you to watch how our code works, right? Coding is basically a top to bottom script, unless of course you do flow control or you do method calls. Okay, so first line, it runs this. Next line, it runs that. Okay, so we're on this line. And so when I call new car, oh, now we're here. We're in the car class. It does what? It basically, okay, sets make, sets model. You notice how these are null? Null is just a word for nothing. If it has no value, it's not zero, okay? This is actually insanely complicated for non-programmers to understand a lot of times, especially when you have a string. So if you have a string with quote, quote, it's not null, it's an empty string. Null is complete absence of value in any way, shape, or form, okay? And the good news is you can test for null, and we'll get to that later. But complete absence of value.
You said we had to set miles to 0. You set it to null and it still worked.
No, because what will happen is if I set it to null, right, and then someone adds miles, it's trying to add miles to null. Can't do that, okay? It would work. You are allowed to set values to null. It's a very, very common thing in Java programming. You set something to null to indicate it's freaking null. Like, there's nothing there yet. Because null can be tested for. You know, I asked for the square root of something. Well, if I ask for the square root of -1, what happens? So one option is you just blow up. The other option is you just return null. Hey, there's no value for this. Empty set. You cannot solve this problem. That's an option, right? So you can't test for it. It's very common to have things as null. But you cannot use it for anything other than really testing for it.
So can you, so there, like it says, okay, color null and color black. So it's like replacing null,
Yes.
but you can't do arithmetic.
No. So you're just setting the value.
This color, null, but then the fact that it's equals color is
Yeah.
setting color to black.
Yeah, so
Both
the
of those,
object-
it's two.
The object's color is null. The incoming color for the constructor is black.
So it's showing you how it changed.
Yeah.
Where it's-
Well, this is actually showing you two different variables because we are on this line. We have not run the line yet. Okay, so it pauses on the line before it runs the line. Okay, so now if I do it, color of black, color of black.
Oh,
Okay, this is a really, really nice feature that they just added less than a year ago, where it pretends like there's comments beside it, so you can see live what's going on. Love this feature. If you're doing debugging, I saw it and I cried a little bit. It's just so beautiful. And then I cried a little bit less when they put it into PyCharm while I was doing Python, because IntelliJ almost always gets all the features first. Then they disseminate them out to the other IDEs, because IntelliJ is their flagship product. This is their big one that they use. Okay? All right, so we go through. We keep going through. It doesn't actually run. It doesn't actually run the squiggly brace, just so you're aware. Okay? And now we're back here, right? So now we come down, and now Mustang is car at 443. That's a memory address. Next week we'll actually learn how to. Actually, I may show you this week and just tell you not to think think too hard about it. I'll show you how to actually make it so that it is something useful. Like, you know, it might actually print the make and model out instead of just being car at 443.
Yeah.
So if you have 1,000 cars, car at 443, not super descriptive.
That really bad chat.
Yes, that is exactly what that is. It's the IRC days all over again. Okay? But see, what I want you to kind of see is I want you to kind of see how the flow of the program's working, right?
Yeah. Where did you go to run the debugger? Not that I'm gonna, but I just.
Just right click on the main and do
Oh, okay.
debug. Okay?
Gotcha. Thank you.
Right? And so what happens is, and the key that you have to understand about this program is top to bottom, that's all it's doing. Run this line. Now, if you call a function, method, what happens? Jumps over to the method, runs it from top to bottom. Once it's done, it comes back to the same line and continues running top to the bottom, okay? This is the way all programs work, except when exceptions happen, okay? Now, you will all see lots of exceptions. This is the equivalent of Java errors, okay? What happens is that in the event that an exception happens, program execution for wherever it is halts. Okay? Now, this is really easy to illustrate, and for all of you who will be listening to this tonight, you're gonna hate this part. So I'm gonna walk away from my laptop. This is not a studio. I'm gonna be over here talking for like 5 minutes, and you're not gonna be able to hear anything on it, so you'll just have to fast forward. Just letting you know up front. Okay? So, alright, so we're gonna erase all this. Yeah, I hate it. Okay, so say that you have a program, and this program has lines of code. Okay? What's the way it's gonna execute? This line, and this line, and this line, it's just gonna go straight down. Here's a function. Here's a function. Okay? This line calls this function, right? That is the worst arrow ever made. And then right here, calls another function. There's no reason you can't do that, right? Because you may want to break down your problem. So like you want to basically, you set name, going back to my example about how it used to be that we would only have one name and now we have two. So you call this function, but you realize you have to actually split up your names all the time. So the same logic is over and over and over again. Let's clean that up. I'm going to make a method that will split the name for me, right? So now you actually have two methods. So imagine this is the main class. This is the function that is the set name. And then this is the function that's split name so that it can get both of those names back, right? Normally, what happens? Executes one, executes two, comes in here, executes one in this function. So we'll call this, f prime. Executes, f prime line 2, f prime line 3. But then this runs over here to f double prime. I don't know what more prime than prime is, right? Huh? Function Optimus prime. And it executes these three things. What an exception does, say like an exception occurs right here. An exception, creatively enough, is meant to be something exceptional. Something you weren't expecting to happen. This shouldn't happen. What will happen? Actually, let's do this. Okay, so second line calls Optimus prime. What will happen is if this exceptions, it will crash up through what we call the stack without executing any more code after. So if this causes an exception, so like there's one of the ones I like to use is the divide by zero exception, right? Which is basically called an arithmetic exception. This, instead of going on this is an exception, this says I have an arithmetic exception and it crashes back up to this line without ever executing this line. It crashes up to this line. Now, if this line does not have the ability to deal with that exception explicitly, and I'll show you how to deal with an exception. If it doesn't have the ability to deal with the exception, what happens? Crashes back up to this line. So this is not executed either. Once it's up here, if there's nothing that handles the exception there, the program blows up and dies. Okay? So you have to be kind of careful. Exceptions are extremely useful, but it destroys the normal flow of the program and just starts flying up. Back in, like, if you do exceptions in a language that actually does not have good memory management, this is a big problem. Create a variable, allocate memory for a variable, deallocate this exception, this is still hanging there. That memory is still there, okay? So try to keep exceptions as truly exceptional. And I'll show you, and this is, like, I tell you this and you're probably in your mind like, okay, well, what's truly exceptional? The truth is, it's hard, right? Some people have different values than others, and there's nothing that stops you from throwing your own exceptions or doing that type of stuff, okay? So it's kind of hard to figure out. It is what it is. Don't feel really bad if you don't figure it out, okay? It just takes time to practice. There's a lot of things you're gonna be doing in this class that you'll do wrong, not because you're an idiot, not because you don't understand the concept. You're gonna do it wrong because you haven't been programming for 10 years, okay? It's okay. That's why we do code reviews, kind of help you. Most of my code reviews, when you get further along, are less about you did this wrong, you did this wrong, you did this wrong, more about you could probably replace this function. This class probably needs to have this. It becomes much more of a, you need to understand the concepts. This is how you're going to be a better developer, not a, you did it wrong. Your program worked perfectly fine, and I'll still mark it up like, still mark it up as if it was like an elementary school term paper. Like I'll tear it apart, not in a bad way, in the way of, here are better ways to do this, okay? So don't feel it.
Can we go back to this?
Yeah.
So if that was gonna there were no exceptions, how would that?
So if there were no exceptions, it would be 1, 2, come here, 1, 2, come here, 1, 2, 3. The return comes back to this line, it executes 3, return goes back to 2, and then it would complete out. If you don't do anything to fix the exception, it's just slam, slam, slam. Like basically, it's like watching like the X-Men juggernauts through your program. It just blows a hole clean through your program until something either catches it or the entire system explodes.
I have a question.
Yeah.
I've heard this term stack before. Like, what exactly is that?
Creatively enough, it is exactly what it sounds like. Stack. These all stack on top of each other, right? So this calls this function. So we call this f prime, right? So once it calls this, it puts this on the stack.
Which one, F?
The main. Let's call this main. So this is main f prime, okay? So main is currently running. When it calls out to another function, and this is all architecture. You don't have to understand this all that much, okay? The stack now has main on it, right, while it's running f. F then calls f prime, so then f is put on the stack. F prime runs, and once it's done, it pops that off the stack to run f again. So you can imagine that this is basically f at line 2, this is m at line 2. It basically saves off what happens, okay? If you call enough of these, the stack can fill up your program, crash. But that usually only happens when you're doing something called recursion. So for the most part, that's all it's doing. The stack is just basically internally, not something you necessarily have to deal with. Internally is just, say like you call this function, and it's just repeated function calls. So it's 10 lines down, which can happen. So this function 1 calls function 2 calls function 3, and function 3 calls function 4, all the way down to 10. This stack has 10 function calls on it, or 9 function calls on it at the bottom when it's working with function 10. So that when it's done, it can go back to function 9, back to function 8. That's all stack is, okay? Don't worry if you don't really truly understand that concept. I don't need you to understand that concept right away. It's not, you'll kind of get a feel for it, and when we get to a point where we're doing recursion, you'll really get a feel for it, because if you screw it up, you'll get a stack overflow error. It basically means you stuff so much stuff on that stack, you're no longer going to hold it, it just blows up. Okay? And you've never truly done recursion unless your program blows up with a stack overflow error. Okay, so you kind of see how it works. Exceptions don't work that way. So what I'm going to do is right here, inside of add miles, I am literally going to cause an exception. Okay?
int a equals 1, int b equals 0, and c equals a divided by b. This will cause an exception because you cannot divide by 0. You can, it's just an entirely different type of mathematics. Okay, there's actually like, there is a mathematics where it's infinity. There's all math involving infinity. It was the most ridiculous thing I've ever seen. Okay. So let's go ahead, and I'm not going to debug it. I'm really just going to, I'm going to go ahead and I'm going to just run the program so you can see what happens. Okay. So you will get these a lot. Do not be afraid of stack traces. That is what this is called. It's an exception with a stack trace. Exception in thread main, Java Lang arithmetic exception, divide by 0. Wasn't anything we weren't expecting. We caused it to happen, right? So don't feel scared. Now what you're looking for is, see this stack, this is called a stack trace, going back to the stack concept, okay? It actually occurred, the error occurred in car.addMiles. It even gives you the line, which is awesome because then you could do this. There's the line it occurs on, okay? IDEs, all about making things simpler, okay? But this right here, that's the line that you did to call it, right? So what a stack trace is basically your program, especially when you're using frameworks like Spring or Spark, and you're deep down, your code maybe 7 layers down from the main running thread. And what the stack trace does is the stack trace basically says, here is all the calls currently on the stack. So what you may see is you may see an error in something that has nothing to do with your code. It's like, you know, core library and a calendar. I've done this actually. I actually set something equal to null, and it took 4 layers down before someone had a problem with it. And so what happens is that your code may be in the middle, or your code's in there somewhere. Okay? So if you see a stack trace, that's all that's happening. An exception is being thrown. And the stack trace is intended to say, this is everything that was going on. Tell, you know, look through this information and tell me. What you're doing is you're sifting through your code, or you're sifting through that stack trace for a line that is in one of your files because you probably did it. I'm not saying you guys are dumb. I'm simply saying there's like 10,000 people working on Java. You probably were not. You probably were the cause of this problem. Okay. So with a stack trace, don't get upset. Don't freak out. Errors are normal. Okay. A lot of people come into class and just like, you had an error. This is terrible. Remember the article, that kind of growth mindset article. Embrace those as challenges. You're going to get frustrated. You're going to have errors. If you do not get errors, there's probably something gravely wrong with what you're doing, or you shouldn't be in this class, which indicates that there's something gravely wrong with what you're doing, which is you're in this class. Okay? If you go 12 weeks without an error, congratulations. Enjoy owning your own private island, because no one does it. Best programmers I've seen, and we're talking, I've met programmers that have an IQ in excess of 190. Like these guys are genius level. These guys are the geniuses who talk down to other geniuses because those geniuses are slow. I am a mere mortal, okay? These guys make mistakes and have errors. You're always gonna have this problem. So don't, just embrace it. You might as well get used to it now because you're gonna have it the rest of your career. Doesn't matter what language, doesn't matter what you do, you'll always have errors, okay? Look through the stack trace, find your code. Make sure you find your code because that's what's going to be the problem, and is figuring out what happened at that point. Okay, so sweet, still have 20 minutes. Okay. Okay. So now that you kind of know what happens, let's show you what happens when something's required, okay? So what can happen is, say like I'm connecting to a database, and I'm sending a query to a database. There's a couple things that go wrong here, right? I could send something bad to the database could reject it. Or there could be a complete connection failure with the database. These would be 2 different exceptions. But you notice that they're both exceptions that shouldn't have happened.
is not really the fault of the database program that happened. It's the fault that you sent in something bad, or you're connecting, or the network IO is toast, right? So what you can do is we can actually test for certain things. So let's go in here. We're going to go into add miles, okay? And we're going to take out our contrived exception, and we're going to put in our own real exception. Just, you know, why not? Okay. Now, I'm going to show you something I'm not expecting you to do in tonight's homework. We're going to get to this in depth tomorrow. If you've done the pre-work, you've already done this. It's an if statement, okay? If you do not understand what I'm telling you, do not panic. Once again, all of tomorrow is about flow control. So you're going to learn about loops, you're going to learn about if statements, you're going to learn about else. We're going to go deep dive into all of them. I'm going to show you like this and this or this kind of stuff that we did inside the crash course, but a little bit more. So what I'm going to do is I'm going to basically do a simple if statement. If miles less than 0. Okay? I don't care if you want to add 0 miles. I don't really care. It's kind of weaselly, but it doesn't matter.
You could turn the car on and turn it back on,
Yeah.
I guess.
Okay? Now what we're going to do is there's a special keyword, throw. Okay? And this is to throw exceptions. And then what you do is you hand it an exception object. Well, we don't have an exception object, do we? So what we're going to do is we're going to do a very simple new, okay? I want you to use exception for now. Eventually we're going to write our own exceptions that will have their own classes, the whole 9 yards. It'll be nice and clean. It'll be awesome. You guys will feel super smart. Right now I just need you guys not to like melt into a puddle of goo. So just use exception. Exception itself, here's the list of all the constructors that it has. And that's the last thing I'm going to show you. You can either pass in nothing. You can pass in a string with a message. You can pass in a string, message, and a throwable. Or you can pass in throwable. Okay? Don't freak out. Basically, throwable is you can pass in another exception. Okay? So say like a divide by 0 error happens, but that's not really, like we knew that it could happen. We may either return a divide by 0 error, or what we may do is we may say we're going to wrap it in our own exception, but we're going to take the original exception and shove it in there so that it's part of this exception, so the user who's trying to debug what's going on knows what the original exception was, not just our like made up exception, right? It's like when Apple takes something that is clearly already in the market, wraps it up, puts an I in front of it, and then says, you see our new revolutionary technology. I sat through an hour-long presentation years ago when Apple came out with notifications saying how it was revolutionary, no one had done it before, and every single person with an Android phone, eyes almost rolled out of their head as they're listening to this because we had had it for 5 years. Right? It was like in one of the original versions of Android notification. They based a copy of it, right? So you can repackage it, and unlike this kind of funny analogy I'm making, if you get an exception, so you catch an exception and then you want to throw a new one, you should always include that exception in there because the more information you can give someone using your program, the better your program is, to a point. You give too much information, it's just over. Okay, so what we're going to do is I'm just going to do a message. No, cannot add negative miles. I don't know why I capitalized miles there. Okay. All right. Now, the first thing you'll notice is what? We have an error. So let's hover over the line, and it'll tell you. Unhandled exception, Java Lang exception. So we've basically said, this will throw an exception if this happens. Someone's got to handle it. Okay? But at the end of the day, we really don't want this to handle it. Right? Like we don't want the same method that's throwing it to handle it. And so the way you get around that is you come up here, and in fact, if you come over here, see this little light bulb right here? It gives you two options of what it will do for you. Now we can do try and catch. You do this a lot, but we're not doing it this time because we want this method to throw an error, right? We want it to throw an exception if you're trying to cheat us. So what we're going to do is we're going to do add exception to method signature. And what this basically does is it adds throws exception, and then that tells anybody using this, hey, if you do something wrong, I will throw an exception.
right? That's the old, you know, like, if you come a step closer, I'll shoot you. If you, you know, like, if something goes wrong, we are going to throw an exception, period. Now, it's no longer this method's responsibility. It doesn't have to do anything with it. Now it's like, okay, I can throw it now. But what it's going to do is now we've made it so that anybody using this method is now responsible for dealing with that exception, okay? And what are the two ways that we just saw you can deal with it? We can either make this method throw an exception, right? Do throws exception on the signature line, which is what we did below, or we can try to catch it, okay? Now, when I say catch it, I mean, it's kind of cool, right? We're talking about like almost like a football or baseball analogy, right? I'm gonna throw an exception, you must catch the exception, okay? The easiest way to do this is this syntax right here. I would type it out, but I feel like that's just kind of belaboring a point that, okay? You surround it with a try and catch. What try says is all the lines inside of this block of code, try to execute them. In the event you cannot execute them because something exception happens, catch that exception, okay? This is dealing with the exception. Remember I told you if you don't deal with it, it just keeps crashing back up through all the lines of code until eventually something happens, until someone catches it or it kills the program. This is how you deal with it, okay? If we know that adding miles might throw an exception, then what we do is we surround it in try. We say try these commands, catch any exception that happens, right? And then in this, the exception is just like an argument, and that is called automatically. This is special syntax. So that's called automatically. So if an exception happens, you can catch it. And then we say, take the exception, put it into a variable called e, and then we can do e print stack trace, and it'll just basically puke out whatever the stack trace was. Okay? Nothing super complicated. I know there's a lot to take in with this, but try catch is not that. In fact, I don't even know that I tell you to do a try catch inside of your homework tonight. I need you to understand it. Like I said, there's a lot of stuff I have to teach you right at the beginning so you don't panic. Exceptions are one of those things. Okay? All right, so let's actually try this. I'm going to force an exception. Okay? So this right here, notice that's our code. Cannot add negative miles, right? So it's an exception. So what's happening is, we can actually watch it again. Okay, so we're going to go down. It executes normally. I'm skipping over. That's why it's not going into each function call. I don't want you to think that it's not running the functions. I'm just kind of skipping over for time's sake. Okay, now we're at the code where we're trying to cheat the system. So we go in. First thing it does is it says if miles is 0. Now notice there's all that code below it. Throw exception. It does not execute that code. It jumps right back up to the next level up. But then it sees a catch. And so it goes in here. Okay? Stack trace is basically the exception. And then we do print stack trace, which basically what it does is it takes the exception and then does a system.out print on the exception for us, so we don't have to do it. Questions about exceptions? Okay. You will run into exceptions. The more complicated your programs become, the more exceptions you're going to run into. Sometimes you're going to want to throw your own exceptions, like what we just did. Other times it's going to happen. It can happen. It will happen. Okay? So that's all exceptions are. It's just this kind of concept. It's an object, just like any other object, but it's handled differently in that it crashes up through the program stack. Okay? Now, there's one more concept today, and then your brains will be given a rest. You will get no more new information, but you will also have to do your homework. Okay? So, the concept is called overloading. Java does this cool thing And what it does is it says every class can have as many of the same named methods as you want. The only caveat is you must pass in, you must have different arguments, okay? So if you have a string argument and a string argument, you can have a method that has just a string argument with the same name. If you have 3 string arguments, you can have a string argument, you can have a method with the same name that has 3 string arguments, okay? There's no reason you can't do that. As long as the arguments are different types or different counts, right? So in other words, another one is, if you have a string, string, int string, you can have another method of the same name with a string, 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 or int string, string. Basically what they do is the way they can tell them apart is they take each of the types inside the arguments, the name plus the types, and then say, okay, this is what I got. So as long as you have a different set of arguments, it's totally acceptable. We're gonna, before you kind of panic, I'm gonna show you. One of the most common ways to do this is with your constructors. Overloading constructors is very, 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 very popular and useful. The reason being, it's actually, there's a specific name for it called telescoping, where you have multiple constructors, each doing multiple things. So for instance, right here, say like we don't care about the color or the year, right? So maybe there's a couple things. We need make and model. The color, say like we're introducing these vehicles in, but the vehicles may not actually have a color yet. You know, they might just be the raw material where we're putting it in, and later on someone's gonna come in and do color, okay? Now, admittedly, we have a set color, so this is totally not possible, okay? So what we can do is we can actually create a brand new constructor, public car, I'm gonna do string, make, string, model, int, year. Okay, notice these two methods have the same exact name. They're both constructors. But if we pass in 2 strings and an int, instead of 2 strings or 3 strings and an int, it'll call this method. It's perfectly legal. Okay, and then what we do, and in fact, this is the telescoping methodology, is what you do is you basically do this, and you pass in, if you do this, what happens is it calls the constructor for this object. You do this, and you can basically say make model. Actually, before I do that, I'll show you the simple way. You do this dot make. Here. Okay, except color just remains null. Okay. So this is the way you would manually do it. This means that the color remains null, which we accept, right? We can set color. So if we don't have a color yet, we can call this constructor anyway. It will set everything else but that. Make sense? Okay. Now, like I said, the alternate way, which I was showing you initially, if you don't want to do it this way, in fact, most people don't do it this way, because the truth is, what did we just do? In programming, we did something that is generally a massive red flag. Copy paste. If you were doing copy paste, you've probably missed something. Okay? As you get better, as you go through the semester, you'll see this more and more and more and more. Copy paste is bad. Because if you're copying and pasting something, you probably can put it in a method, right? That's all a method is a series of steps that can happen over and over without you typing them in. Now, the only reason this is going to seem complicated is because this. Okay? Now remember, what is this? This is a reference to the object that you're currently in. So what I can do is I can actually call the constructor in this thing, in this specific object, by just doing this colon, or this as a method. And then what I do is I take make, model, and then since the third one is color, I'm just going to pass null in here. So that's the shorthand for it.
Did you have to pass a null there?
Yes.
In order for it to...
Yes, because basically what I'm doing, when I did it before, I just did everything myself. But if you have like 10 of these, that's a lot of extra work and a lot of extra code. Plus what it means is that in the event, say we want to start miles at 100, I have to go through every constructor and change miles to 100. But here, by using this is the equivalent of saying car parentheses outside of the object. And then what we do is we pass it in, and we're basically calling that first one, but we're forcing null in. So this right here is a convenience method for anybody using our class to not have to provide a color. Because anybody not using it could easily have just done null there as well. They could have called it the exact same way with the null inside of the color. And you can totally do that. There's no reason you can't do that. Okay? So overloading is basically that. You can overload anything you want. So constructors are useful to overload, but say like right here, add miles. Say like we want to do something like public int add mile, right? We're going to make it really, really easy. They don't have to pass in anything. We're going to add 1 mile to the odometer. That's all we're going to do. That's what this function's purpose is, 1 mile, okay? So all we would basically do is call, oh wait. No, that's not overloading. Although it's the same, like what I was trying to explain is the same principle. And then there's an unhandled exception, which means I'll just add it to the method signature. Okay. So this isn't actually overloading, it's just calling another method, but it's the same basic principle. So say like instead we wanted to do add miles, but we only wanted to add one. Now that doesn't work as a great example. Hold on. Okay, so we're going to do add miles. We're going to take int miles. We're going to do string trip. Now we have no logic to deal with this, but maybe what you want to do is in this instance, you basically set trip to a this.trip or last trip or something, but then you would basically say add miles and you would pass in miles, right? Okay, so that's the kind of stuff that I'm talking about. When you overload things, you can have multiple. I want you to know that just because a lot of times you want to do constructors like that, because then it saves you some code. Because we have a couple of scenarios where make and model is all we know. Okay, well then you make a constructor with make and model, sets the year to whatever the current year is by default, right? So there's all these type of things you can do. And when you look at that, when you do the exception, remember how you have the 4 lines, you can pass nothing, you can pass a string, you can pass a string inferable, or you can just pass a throwable. All 4 of those are these overloaded constructors. It basically says, we have 4 constructors, pick your poison. This is much more verbose than any other language, well, any other scripting languages. The scripting languages allow you to set defaults inside of the functions and stuff. This doesn't, but it's nice because then each one has a separate function you can go look at and see what it's doing. Okay. So I don't ask you to do much with exceptions or overriding, or overloading, sorry. I don't ask you to do much with that with your homework tonight, okay? So your homework tonight's available to you. Oh, look at that, man, it's like 11:58. Boom, baby. Getting good at this teaching thing, or at least timing it. I don't know if you guys think I'm doing good at teaching. So Monopoly, okay? Basically, what you're gonna do is I give you 3 classes that I want you to implement with methods in them. The 4th class, I want you to come up with your own. Think of something on the Monopoly board that you can use, right, in a Monopoly game that you can create a class for. Create getters and setters, okay? At a base level, really all I want you to do is create the class, create getters and setters, and then there's a couple that actually ask you to do specific methods. But I want you to get creative, right? Especially in your own class, like the one that you think of, because like I said, I implement 4, I give you 3. So there's one that you actually have to think for yourself. There's 2. In that class, think about what needs to happen. Does it ever need, do you just pass it in a constructor and then you're never allowed to change it? Are there things that change about it? What do you want to do? Okay. Now, most of the homeworks are going to have a hard mode. In order to pass this class, you need to get your homework done on the normal mode. Hard mode is, especially the first couple weeks, you go out there and you finish easy mode or you finish normal mode in like an hour. Okay? Go for hard mode. Because one of the things you have to understand is this isn't college. Okay? I will go right now and print you out a certificate saying that you graduated, and it's about worth it about as much as if you had actually graduated. Right? People don't look at the certificate, they look at what you know and what you don't. Okay? So the harder you push yourself, you're gonna know, and the more you're gonna have to show for it at the end, okay? I've actually told several classes this. It's like, if you want a piece of paper that means something, go get your degree. That piece of paper means something. Should it? Probably not. But it does. People place value in it. You're here to learn as fast as you can, as much as you can, okay? So push yourself as hard as you can. Don't slack off, because you're not hurting me if you slack off, right? You're basically paying $200 a day to be here and slack off. I've had students that got through the entire semester and basically didn't graduate because they got halfway through, they didn't want to quit, they weren't doing any work. I have no idea why. Like, motivations are still lost on me, okay? But push yourselves. That's where hard mode comes in, okay? I did not give you in this class all you needed to know to do hard mode, nor will I ever, okay? Hard mode is take this concept and think for yourself. I did give you links for you to understand what you need to do, but basically hard mode is you're gonna add a dice class and the dice is gonna be able to be rolled randomly, which is pretty cool. And then a couple other things, all right? So that's your homework for tonight. I wrote it this morning, there's probably typos in it, I apologize. But you should all have it in your current. If you don't, let me know. Has everybody seen Monopoly as part of your list? You may want to go on online, I wanna make sure you guys can see it. Can you see it?
Yeah.
Okay, then you all, that's get it done, it's for tomorrow. And congratulations to your first real programming assignment. And there's a lot to it, okay? So don't think it's gonna necessarily be easy, especially since you all are trying to like just digest the concepts. One thing to note is you are probably never gonna feel comfortable in this class, ever, okay? The way they describe it is about the time that you hit Monday, you're really gonna understand the previous week's stuff. You're never going home going, oh yeah, I totally got this, right? It's gonna be unsure, it's gonna be uncertain. You're gonna know enough to do some damage, that's it, okay? That's why you have homework every single night, because I cannot beat these concepts in your head verbally. You gotta program, you gotta do them, okay? So, you're good to go. If you have questions, let me know. It's probably gonna be the first, I don't know, like, I haven't tried this homework assignment yet, so you guys may finish it in like 30 minutes, and I'll feel like an idiot. At which point, congratulations. You may not, it may be way too hard for you. I don't know. I think it will be okay. You had to learn a lot of stuff, but this will at least give you a lot of practice, okay? As soon as, it's either right before or right after I get back, I'll push up the class notes so you'll have this program, so you can refer back to it and remember with fondness the experience in class.
That's it. I'm only allowing you to remember with fondness. You're not allowed to remember in any other way. All right, I'm gonna wipe this out. Oh, wow. If anybody wants to hang around for 2 minutes while I push this up, you're welcome to kind of see the Git process for like the 900th time. You don't have to. You can go if you want to get started in your homework. So we have no class notes directory. I have no class notes repo yet. This is the first time I've actually pushed class notes up for this. So I'm gonna just do new repository, call it class notes. I'm not gonna put a description. I feel like it's pretty decent. Keep it public, create repository. Once again, it gives you the instructions. GitHub was kind of the first group that did this. I could kiss whoever could do it, who did this, because now everybody's kind of following this, and it's beautiful. When you first start, it's not the do this and do this and this. It's just like, here's a list of the exact commands, because this is actually, if you notice, this is actually the exact commands for your repo, okay? All right, so first one is git init. So we're gonna do git init. This initializes, basically creates your nifty little .git directory, but it's only a local repo. Next line, git add. I don't have a readme, I'm just gonna do git add. I'm gonna give it the directory. Status. Now you'll notice I do git status after every single command I run to make sure that it's where I think it should be. This is a force of habit for me. You don't have to do it. I know most people don't do it. I do it because I'd rather run the extra command and say, okay, this is what I'm expecting to see. Okay, so then we do, I want those.
You know when you get added, you're creating that directory?
No, when I do git add, I'm adding it into staging. So and these are all the files in that directory. Do git commit -m, adding day 2 project. Okay, hit status. Now you'll notice it says nothing to commit, working directory clean. Because all of the changes have been added in. Then we do git. So I've done those. So now so I did git commit. And I'm going to do git remote. I usually just copy these two. Okay. For now, I'm just going to copy the first one. This is doing nothing other than adding what we call a remote. Basically saying, here's a remote server. You can add as many of these as you want. It's the same thing as adding like your friend's phone number to a Rolodex or into your Rolodex. A phone. Every once in a while, I just say these things. Like I always say I listen to books on tape, which just dates me by like 20 years. When I really use Audible, right? That's cool-ish. Okay, so basically, it's going to do a remote called origin, and this is the URL for the remote origin. Finally, last line. Git push. Now, most of you can do git push normally, right? Once you've created the directory, you fork the directory, you can do just git push. What this is saying is, I want to git push to the remote origin master branch. What the -u does is the -u says, from here on out, connect those two branches. Okay? So it understands the default behavior now that this branch needs to be pushed up. Okay? It does all of its pushing uppy things. Now if we refresh, there you go, day 2. So you all can clone this repo, you can fork the repo. My advice for class notes is don't fork it, okay? If you just do the clone, you're not gonna be able to push up, you're not gonna need to. If you just do the clone though, what you can do is after every class, you can go back into the same directory and do a git fetch, or I'm sorry, a git pull, and it will go up to that remote and pull down all the new stuff. It makes it really, really easy. You never have to worry about like, oh, I'll have to push it to the fork and stuff like that. So just if you want your class notes, just git clone this repo. Okay? Okay. Questions? That helped. All right.
So this won't have the recording name.
No. Hold on one second.